Hello students, we have learned how to differentiate trigo functions. So in this video, we're going to learn how to differentiate exponential functions. So do get ready a pen and some papers and practice along with me. Right, let's look at the concept needed. Basically, the derivative of e to the power of x is just e to the power of x. So supposing you're asked to find the derivative of e to the power of ax plus b, so what we do is whatever you are given, the first step is to just write it down. Then the second step is to differentiate the power. So in this case here, if you differentiate ax plus b, you will just get a. And then you just shift the a to the front. That's how we end up getting a times e to the power of ax plus b. This is just that simple. So let's have an example. Supposing I'm asked to find the derivative of e to the power of 3x minus 2, like what I've mentioned earlier on. Whatever you're given, in this case here is e to the power of 3x minus 2, just simply write it down first. And then you multiply with the differentiation of the power. And the power is 3x minus 2. You differentiate 3x, you get 3. You differentiate negative 2, you get 0. And the next step is just to shift 3 to the front, to the front of e to the power of 3x minus 2. And this is how you do it. So the concept is rather simple. But the problem solving will be a bit challenging. So let's look at what are some of the problems that we are required to solve in the next few slides. Right, so let's look at the first questions. So the first questions we're given y equals to e to the power of x over x and x more than 0. Right, it kind of makes sense to have x more than 0 because if x is equals to 0, right, you can't have something divided by 0 which is undefined. And in this case here, of course, x can be negative, but in these questions, they would rather have x more than 0. All right, so find the range of values of x for which y is a decreasing function of x. Okay, so beside knowing how to apply the quotient rule, obviously here we have to apply the quotient rule because what you're getting is a fraction. It's e to the power of x over x is a fraction. We also need to know what is the concept. You know, when you see this sentence, when you see the y is a decreasing function, what is the concept that you can connect to? You connect with, what's the concept you can connect with? Right, so in this case here, if you were to remember, if y is a decreasing function, then the gradient functions will be less than 0. Okay, so we're going to apply quotient rule first to differentiate to find our dy dx. So this is the usual steps that we do. Let your numerator be u. So when you differentiate e to the power of x, you just basically get back e to the power of x. Let the denominator be v. You differentiate the v over the x. You get 1 because you differentiate x, you get 1. All right, so let's write down the formula for the quotient rule. I think it's important that you write down the formula because to avoid making mistake. To avoid making this mistake. Okay, that is not correct, right? So it's good to write down the formula. And if you write down for the problem solving, if you have done like maybe 20 problem solving, and if you keep writing down the formula for the quotient rule 20 times, more or less it will be in your long-term memory. Okay, so let's substitute the values for v, which is x. The u over the x is e to the power of x. Let's just plug in now whatever we have there. Okay, right. And then what we're going to do next is you'll see that you can actually factorize e to the power of x. This will be your common factor. So we can put it up. Okay, right. So the next thing is to apply this concept here as what I've mentioned just now. That if y is a decreasing function, that means dy over dx is less than 0. All right, so we're going to let, yes, this equals less than 0. All right, so we understand from what we are given here that x is a positive value. So therefore, x squared will also be a positive value. So if your denominator is a positive value, right, if this guy is positive, then your numerator has to be negative, right? So that negative divided by positive then will give you a negative value. You need to satisfy this condition. The condition is it has to be a negative value, right? So therefore your numerator has to be less than 0. Okay, but we all understand for exponential function, if you have forgotten how the curve looks like, the exponential functions, the curve what looks like this. So you can see that y is more than 0, right? Which means e to the power x is more than 0. It's above the x-axis. So how do we go about solving it? So it says that note that since e to the power x is more than 0 for all real values of x, so therefore x minus 1 has to be negative. And what we get will be x less than 0, x less than 1. And we have an earlier condition here given, x must be more than 0. So we're going to combine these two conditions, and we end up getting the range of values of x will be more than 0 and less than 1. And this is how we solve the first question. Right, let's look at the next questions. If you look at these questions here, it's quite straightforward, but I have to caution you because there's so many e to the power of 2x. Not so many e to the power x, 2x, sorry. There are e to the power of 2x, it's also e to the power negative x. So you have to be very careful with the differentiation of the exponential function. Like what I've mentioned earlier on, if we do the recap, right, the derivative of e to the power ax plus b is easy. It's just a times e to the power ax plus b, right? However, if you are seeing so many e to the power of 2x, e to the power negative x, that kind of thing, it may be confusing. So we have to be very careful in our steps, right? So we need to find our dy dx first, because basically we need to show whatever dy dx I have here plus 4 times y. The final result must be this answer. This is my final answer that I need to show. Okay, right, so that's go about finding your dy dx. Okay, right, so a is a constant, a and b are constant. Constants basically are just like some numerical value lah. So it can be like 2e to the power of 2x plus 4e to the power negative x, that kind of thing. Right, so we're going to differentiate a e to the power of 2x. All right, so we're just going to ignore a because a is a constant, just going to ignore it. And then we're just going to write down e to the power of 2x first, then times differentiation of your power, which is 2x. So you differentiate 2x, you get 2. So let's see what we end up with. Okay, so like what I explained just now, basically you just leave your a alone. Whatever you're given, write it down first, and then you differentiate the power. So you differentiate the power 2x, you get 2 here. So let's do the same for b, the second one. Let's do the same. Let's erase this because too many things. So for the second one, b, just ignore your b. Whatever you're given, write it here. Okay, and then differentiate the power. So look at what I've done here. You see, when you differentiate the power, you end up getting negative 1. You differentiate negative x, you get negative 1. So it's very important you put a bracket here. You see? So brackets are very important. The bracket here. And of course, close it up with another huge bracket because you have one bracket here, right? So you need another bracket to close up the thing. Okay? Right. And then we're going to simplify. Okay, we're going to simplify. So how do we simplify it? Yeah, basically you just bring the 2 to the front. Bring this to the front. So 2 times a will give you 2a. Right, and this one here, the positive sum the negative will give you negative. Okay, right, so this is what I mean by you have to be careful. All right, so the next step is I'm just going to substitute all this, substitute this into here. Right, and plus 4, and then substitute y here. Okay, let's see what happened. Okay, this is what we're going to do. Right, so we end up having 2a e to the power of 2x minus b e to the power of negative x plus 4 times y. So the value for y is this. So that's how I end up getting this. Okay, right. And then we're going to simplify further. How do I get 6a e to the power of 2x? Right, so I'm going to erase this. I think that's erase this because it kind of looks very messy with so many things on the screen. I like to keep it neat. All right, so what we have here is, if you're going to simplify this, you will have 4a e to the power of 2x plus 4b e to the power of negative x, right? Okay, so we're just going to take this plus this. That's how I ended up 6a e to the power of 6a e to the power of 2x. And you can see that we can simplify it further. This one with this will give us 3b e to the power of negative x. Okay, right. And we are going to compare whatever we have with what we're given. Okay, and you can see that the coefficients of e to the power of 2x is 1. So we need to compare it with our 6a. That means our 6a will be equals to 1. And the coefficients of e to the power of negative x is negative 1. So this will be compared with 3b. So from there, I can find the values of a and b. So 6a will be equals to 1. A will be 1 over 6. 3b will be equals to negative 1. So b, or negative 3b equals to 1. So b will be negative 1/3. It should be 3b equals to negative 1. It makes more sense. And b equals to negative 1/3. Okay, so this is how you find the value of the constants a and b. Alright, so let's look at the next questions. So the way to solve these questions is rather similar to what we've done earlier on. The only thing is that you have to be very careful with your manipulations, algebraic manipulations, because here we're supposed to find the second derivative. And this is where at this second derivative that you have to exercise a lot of care, okay, a lot of care. So what do I mean? So let's take a look. Let's find your dy dx first. So finding dy dx is easy. You just apply the product rule. Let u to be e to the power of negative x. So du over dx will be just e to the power of negative x times negative 1 gives you negative e to the power of negative x. And then let v be x squared. So dv over dx will be just 2x. And then plug into your product rule formula. All right, so the next thing is that factorize. Okay, in this question, if you want to have a less stressful time solving this question, then it's please do apply this. That means simplify the expressions before you proceed. So if you look at what we have here, we have a common factor e to the power of 2x. So let's factorize it. Okay, so when you factorize it, you will see that you have something multiplied with something, but you can apply the product rule again to find your d squared y over the x squared. Okay, and then apply the product rule again, and because the product rule, I've already written it here, so I'm not going to write it again. So basically, you just plug in your u, which is your e to the power negative x, and then your dv over the x, which is your 2 minus 2x here, and then so on and so forth. Okay, so on and so forth. Okay, so the next step is again factorize your e to the power negative x. Factorize your e to the power negative x. Right. Okay, so how do I end up getting negative 2x plus x? That's because if you look at it, I have a negative here, right? And a positive. So the positive times the negative will gives me a negative here. And then a negative and this negative give me positive. Positive times positive, that explain this positive here. But if you are sometimes in the exam you may panic a bit. So I think it's good that you, yeah, just do one extra steps, as in you simplify it first. Okay, you have a negative here and a positive here, right? You simplified it to get a negative first. Okay, so that will minimize, that will reduce the chances of you making mistake. Okay, right. And then you can just take negative 2x minus 2x will give you negative 4x. So this is what we have for the squared y over the x squared. So we will substitute everything into this expression, okay, and find the values of k at the next slide. Okay, so from the earlier slides, this is what I have for your dy over the x, and this is what I have for your d squared y over the x squared. I'm just going to plug everything onto this expression here. Okay, this is what we get. So we have e to the power x first, okay, followed by your d squared y over the x squared, okay, followed by 2 times your dy dx plus your y, which is e to the power negative x times x squared. Okay, watch out for all these brackets. Okay, you have to make sure all the brackets are there correctly. Otherwise, you will not get your correct answer. Okay, we're just going to simplify whatever that's inside here. Basically, just expand. If there's a bracket, just expand it and then simplify. Okay, so you have the huge chunk of thing there. Don't worry, a lot of things will be cancelled off. Okay, you'll see that this and this will give you 0. So that will be gone. I have 1 and then you see this and this add up will gives you 2x squared e to the power negative x, right? So this and this and this will be gone. So finally, you're only left with 2e to the power negative x times e to the power x. Right, so e to the power of x. Yeah, so you're left with that. Then so e to the power of x times e to the power of negative x. Basically, it's just e to the power. Remember, e to the power of a plus b, so it's just x plus bracket negative x. So gives you e to the power of 0, and that gives you 1. So you end up just getting 2. So therefore, k is equals to 2. Okay, so this is how you do it. Alright, so let's look at the second last questions. Okay, just bear with it for a while. We are ending this video very soon. So for the second questions, you're given the diagram giving a curve, and this curve cuts the x-axis at point A, y-axis at point B. So the first part is relatively easy. Okay, so to find point A, basically you just let x equals to, to find point B first. Point B is easier. Basically, you just let x equals to 0, substitute into your equations of the curve. So e to the power of negative 2x. If your x is 0, you end up e to the power of 0, right? E to the power of 0 is 1. So you have y equals to 3. So therefore, point B is easy to find, 0, 3. So for point A, basically, you just need to let y equals to 0. So this one involves more steps. Okay, if you would involve the logarithmic law, you know your ln is actually log base e. Okay, so you have to bring, so if you have ln e, which is basically just log base e, it gives you 1, right? So I'm going to bring ln to both sides. Alright, and then apply the power law here. This one, your power law. Okay, bring the negative 2x to the front, and then, oh, sorry, this one, don't have this. Erase off. Wait. Erase off. Okay, because I already bring it here. Bring it to the front. So that one should not be there anymore. Alright, and then 4, I can write 4 as 2 squared. So that I can bring the 2 to the front. So that you see the 2 and the 2 can cancel off. You see, the 2 and the 2 can cancel off. And then ln e will give me 1, right? So I end up negative x equals to ln 2, x equals to negative ln 2. Alright, so your coordinates of A will be negative ln 2, 0. Supposing if you don't want to leave your answer as in terms of ln, which is the exact value, because the question never said leave your answer as exact, right? You can actually use a calculator to work ln 2 out. I don't have a calculator here. You just work it out and put it to three significant figure. That's fine also. Okay, so that is just part I. All right, so for part 2, okay, what happened is that you have a normal at the point B, and this normal line meets the x-axis at point C. Ask to find the coordinates of C. So we do remember that the normal line is a good friend of a tangent line. So we usually would have a tangent line. Okay, the tangent line means the line will cut B. The line will just cuts the curve at point B, right? So to find the tangent line, basically we just let dy over dx equals to, we find dy dx, sorry, not equals to 0, we're not finding stationary point. Sorry, we just find dy dx, okay, and we find the gradient of this line first. We find the gradient of this line first, okay? So let's find our dy dx. All right, so you differentiate 4, you get 0. So whatever you see here, you just write it down. Okay, so that's why the beauty of exponential differentiation of exponent function is that whatever you see, you just write it down and then multiply with the differentiation of your power, which is negative 2x. So differentiate negative 2x, you get negative 2. And then the negative and negative give you positive, so you end up having 2e to the power negative 2x. All right, so we're going to find the gradient of that tangent line at point B. So we're going to substitute x to be 0. And therefore, the gradient of normal line will be negative 1 because tangent and normal multiplied together gives you negative 1, right? So gradient of normal line will be negative 1 divided by gradient of the tangent line. So negative half. To find equations of any straight line, okay, remember this formula. What formula am I referring to? Y minus y1 equals to gradient x minus x1. So your x1, y1 is the point that you know, which is 0, 3. And of course, your gradient is negative half lah. So you simplify, you get the equations of the normal line to be y equals to negative half x plus 3. And if you look at this particular point, see, you know that the y axis is the y coordinate is equals to 0. So let y equals to 0. Okay, negative half x plus 3 equals to 0. From there, half, that's a, yeah, negative half x equals to negative 3. So half x equals to 3, so x equals to 6. So therefore, your point C is 6, 0. Okay, right, that's how we do it. Right, let's congratulate ourselves. We finally come to the last questions. So for the last questions, we're given a curve which is y equals to e to the power of 2x over x plus 2, where x is greater than negative 2. All right, so basically x is going to be negative 2. That will make a denominator to be 0. Something divided by 0 will give you undefined value. So therefore, x is more than negative 2. Right, so we asked to find dy over dx. Okay, so we have to use the quotient rule. So we're going to let the numerator be u, denominator be v. So if the numerator it's e to the power of 2x, you differentiate it, you get e to the power of 2x times 2. So there's 2e to the power of 2x. Let the denominator be v. So differentiate x plus 2 will just give you 1. Plug into your quotient rule, write down the formula. Start with v du over dx minus u dv over dx over v squared. Plug in all your v du dx, u dv dx, your v squared. Okay, can you see there's a common factor there? Excuse me, which is e to the power of 2x. We just factorize it and then simplify the one in the bracket, which give us e to the power of 2x bracket 2x plus 3 over bracket x plus 2 to the power of 2. All right, so that is part I, relatively manageable. Okay, so for part 2, we asked to find the turning point, the y coordinates of the turning point. Basically, turning point is just stationary point. Basically, it means your dy dx equals to 0. Okay, right, so we're going to let dy dx equals to 0. And if we do a cross multiply, you see that this will be gone because you're going to multiply with 0, right, to give you 0. So you basically left only 2 to the power of 2x times 2x plus 3 equals to 0. And bear in mind that this is an exponential function, is always more than 0. it cannot be equal to 0. It's more than 0. So it make it inapplicable for it to be equal to 0. So therefore, you're only left with 2x plus 3 equals to 0. So x equals a negative 3 over 2. We're going to substitute the value into this to find your y coordinates. Okay, and here you will end up getting 2 times negative 3 over 2 gives you negative 3. So this will give you e to the power of negative 3. And this will gives you half. Okay, so you end up getting e to the power of negative 3 over half. Alright, so we're going to use the trick that I've taught you before. Look at the new denominator, which is 2, right? Just multiply with 2, because half times 2 gives you 1. Multiply 2 at the numerator, also at the denominator. You end up getting 2 e to the power of negative 3 over 1, which is 2 e to the power negative 3. And then convert this into a positive index that is 1 over e to the power 3. So basically this is just 2 over 1 times 1 over e to the power 3. So gives you 2 over e to the power 3, which is what they want us to find. So bracket shown. Alright, just a little bit more, and then we'll be done with this assignment. Okay, so for part 3, we're supposed to consider the sign of a dy dx, means using first derivative, we need to determine that the turning point that we found just now, whether is it the maximum minimum point. So what do you mean by first derivative? Yes, the table. So from part 2, we found your dy dx, which is very important because I need that particular dy dx. All my animations are all wrong. Hello? Okay, never mind. So this is what I found earlier on, right? This one is what we get at part 2, right? Your dy dx. And how do I get, in case some of you like still a bit confused, how do I get dy over dx equal to 0? That is because we're finding maximum minimum point, right? So that's why we let dy dx equals 0. And when let dy dx equals 0, that's where I get x equals to negative 1.5, right? And the tangent line for any stationary point, it's a horizontal line. That's why dy dx equals 0. So we get horizontal line. Okay. And to remember how we use the first derivative, we find a friend that is very near to negative 1.5, right? The left, this is a point x equals to negative 1.5. So we find one friend on the left and one friend on the right. So how do we determine that particular friend? We use plus minus 0.1 as a guide, right? So the friend on the left will be just negative 1.5 minus 0.1 gives you negative 1.6. And then you sub this particular value inside all your x here, all your x there, and you see that you get dy, the value for dy dx is a negative value. So this is how your tangent lines will look like for negative value. And then the friend on the right will be negative 1.5 plus 0.1 gives you negative 1.5. Sub in your negative 1.4 into your dy dx, you end up getting a positive gradient. That's how tangent line looks like for a positive gradient. And then you combine all these 3 tangent lines, you actually form a minimum point. So therefore, the turning point is a minimum point. Okay? Okay, that's all, folks. Okay, happy learning. Please put in more effort.